Hi everybody, welcome back to another C++ lesson. Today we're going to be talking about how to do input and output using text files actually on the hard drive, so files outside of the program. This can be useful for a number of reasons. Maybe you want to, maybe you have a number of preferences in your program that you want the user to be able to set, and then after the user closes the program, you want the program to remember those settings so it can save them to a text file and then load those up later so that the user doesn't have to go in and put their personal settings in a second time. That's one possible use. You might want to store a list of high scores or something, or some people do. It's actually pretty common to have some sort of error log. So if your program crashes, you can go look in the error log to see what's gone wrong, and that log will persist after the program has closed. So it's not the same as just normal output, and you probably wouldn't want the actual, after you've published your program or whatever, you don't want your user to be able to see the output, so it happens behind the scenes in a log file or something like that. That's just a few examples of what you might want to use text files for. So I'll be showing you how to do that in today's video. So you need to include the fstream library. The F here stands for file or files, so it's just your file stream library, similar to input-output stream. And you don't have to include this, I'm just including that so we can use endl and whatnot. You do still have to use the namespace std. So there are a few different types of classes that are defined in the fstream library that will accomplish what we want. The first is called ifstream, which stands for input file stream. So that's used for getting input from a file that is an already existing file, and you're getting some reading that file to get input from it. Ofstream, which stands for output file stream. So that would be if you're writing errors to a log or something, you're actually outputting data to a file. And then there's also a combination of these called just simply fstream, which will do input or output file stream. I personally don't really like to use the fstream just because I like to keep things relegated and specific. So this particular object is used for input, this one's used for output. Sorry, ofstream is used for output. So I'm not going to be using fstream in this tutorial, but everything that you can do with ifstream and ofstream works the exact same with fstream. So whether that's your personal preference to use that, or if you're trying to understand a bit of code that you're looking at, that's why I included it here. But I'm just going to be talking about ifstream and ofstream. So let me actually open up Terminal here. I made a little directory for us today to play in. So I've made two sample little text files here. I'm using the cat command to read text files. You can find out more about that in my bash tutorial if you want. But so see, this highscores.dat file just has some made up high scores to play with. And I also copy pasted a poem by Robert Frost, so we can practice reading that as well. So let me just save this file real quick. Okay, so I'm just going to save that even though we haven't done anything with it yet. So let's make a, let's practice reading from the high scores file. So I'm going to make an ifstream object, and I'm going to call it infile. You could call it anything you want, but this is a nice, pretty, self-evident name. And then you call the open method, the first method that I've shown you, and so this takes the name of the file, and you can put in some other arguments as I'll show you later, but for now we just want to do that. So this is going to open the highscores.dat file. By the way, this extension does not have to be DAT, it does not have to be TXT, it can actually be anything. If you wanted, you can open up a .mp3 this way, or a .ppt or something, but it's going to look like a bunch of garbage. It's just going to be a bunch of random characters that don't make any sense because it's not a text file. But the actual extension, there's nothing intrinsic about that that makes it a valid file or not. The only reason that's there is to tell the operating system what kind of application to use to open it. But in any case, in order to open any of these files, they have to be in the same directory as your actual executable. So not necessarily the same directory as your source file, but the same directory as what you compile to be into the executable file. So something to keep in mind, but that's why I'm keeping this all in its own little directory. So anyway, now that we've opened the file, and this is the same thing as if you were to open the file in, say, TextEdit or something to read it, there are a number of different ways to actually get input from the file. So the first one that I'm going to show you is if you want to get one character at a time. So I'm just going to make a new character and set that equal to infile.get with no arguments, and then I'll see out whatever that character is. So this will actually get the first character of the file since we just opened it. And so if I go ahead and compile that, we should see, I think, just an N outputted because that's the first character of our high scores file. So indeed, we get an N. So this is one way that you can go about outputting an entire file. You can do this with a while loop of some sort. So while infile.eof, so that stands for end of file. So while that equals false, or you can just use the not operator. So while we're not at the end of the file, get the next character of the file and then output it. And so this will get one character at a time and output it, and we don't want to put an endl after every character. That would look pretty weird. But so this should actually output the entire file, and there we go. And we got an extra little question mark here, and I think that's because this doesn't get set to true until it actually tries to get a character and fails. So if you could mess with this a little bit to make sure, maybe put the conditional somehow in between these, or I guess if you wanted, you could put this on top and then it checks it in between. I don't know, whatever. I'm not going to get into that too much, but that's one strategy you can use for outputting a whole file by getting one character at a time. You can also use the infile.getLine method, and so this will take in a character pointer, so we have to make one. I'll just call this high scores file. And so I'm going to dynamically allocate 128 characters. And so the first argument is what character pointer you want to store the input to, and then the second argument is the number of characters to read in. And so getLine will stop once it hits a new line character. So this will only actually get the top line, but in any case, let me go ahead and output it. So this should show name and then score, and there's a tab in between those. But yeah, there we go. If you want the delimiting, I think it is, character to be something other than an end line, you can set that here as a third argument. So if you want that to be, say, the letter O for some strange reason, you'll see this will only give us up to SC. So let's make sure that that works. Oops, sorry. Yeah, there we go, name SC. And if you want to go to the very end of the file, you can make this a null character, and that will read the whole file. You can also do this without specifying a null character by using the same arguments, but instead of getLine, you use the read method. And so this will, files. This will do the same thing. So it will read the whole file into this array, and then you can do whatever you want with that array. There is also one more sort of important argument, and this uses a string, which we've talked about before. It's an object in the STL used for strings of characters. It's sort of a expandable container. And this is actually a global method, so this is not an in-file method. It's a global function. It's not a method. It's a global function. And so you say getLine. The first argument is actually your input file, your input stream, in this case infile, so it's your IF stream. The second argument is a string, so I'll just make a string and call this high scores. High scores, and this will put the entire, the whole line into the high scores string. So it basically works the same way, just you don't have to specify a number of characters, the number of characters that you want to get. And just the same, you can use the null character to read the entire file into your string. So now you have a string of the whole file, and that can be very useful if you want to do some manipulation. So that's pretty much how you can get input from a file. One final way is you can get it one sort of word at a time. And so this is using, similar to cin, you can use the stream extraction operator. So I can do something like this. And so this is useful if you know the file very well and you know that the first word is not necessarily the second word is not necessary, it's the third word that you want. You could do this 3 times. And then so it will overwrite high scores each time, replacing it with, by the end of, after doing it 3 times, you'll get AAA in there. So that's one other useful way, and this will automatically skip any white space. So that includes this tab and also the end line at the end. So then if we did this one more time, we will get the 10,000, which is supposed to be the score that AAA got. So here you could see out name, high scores, and then see out score. Okay, so this will actually give us name, AAA score, 10,000. So, alright, I think that's enough about how to read from a file. I'd now like to transition into outputting to a file. I guess we never worked with the poem, but that's okay. I don't want to take too much time with this. So let's make an OF stream object. I'll call this out file. I hope that sort of makes sense. And I'll open, let's just call this test.txt. So how you can write to a file. So you can do this the same way that you use cout, which is rather nice. So out file. So the same, I would usually type cout here, but I can just type out file instead and say, anything I want. So this is an output test. And you can use endls and everything. And so this will automatically go ahead and create the file for you. So let me just show you ls. First of all, there's no file there. Run the program, now ls. Here's the file, text.txt. I meant to call it test, but oh well. Now let's read that file, and you see it outputted exactly what we wanted to the file. And that will stay after we close the program. So it's a very, very useful functionality that we have here. An important thing to recognize is that if I output something else, test2, this is actually going to overwrite that file. So let me compile this and then read that text file again. So now it says this is an output test, and I'm going to run that program and then output it again. Now it says test2. So that file was overwritten. So this is something that you definitely want to avoid, like with your high scores file. You don't want to, one option would be to read the file and then output what you've read so far along with the new stuff and output that to a whole new file. But there is a way to append to a file so that you aren't deleting what's already there. So I'll go ahead and show you how to do that using highscores.dat. So say we're going to add a new high score to this. The way that you indicate that you want to append to this file is by adding a second argument to the open method and call this ofstream base : app. So don't worry about this, it's just a namespace, and then app stands for append. So makes sense enough. So now I'll call this new test. Or no, let's make this a score. So I'll call it DDD, and I'll make this score 1000. Okay, you would have to do some checking to figure out whether this score is going to be at the top of the list or at the bottom. For now, let's just assume it's at the bottom, but you could get the input from the file and play with it there. Sorry, I think this is not ofstream base, just ofstream. Yeah, sorry about that. So now let's have a look at our highscores.dat. And you see now it's added DDD onto the end. So we could put in another one just for fun. And I'll run this again just to show you. And so that will put another one on the end. So this is useful for your error log. Like I was saying, you wouldn't want to delete all the previous errors. And also useful for for something like this. So let's see. You can also do a similar sort of thing if you have a character array of something that you want. So let me make one of these. I'll just call it new score and make this, I guess, GGG, and I'll make that score 100. And so now you could just do out file and then put new score in like that, but you can also do sort of analogous to the read method that we saw earlier. You do dot write, and then you can put in new score, and then you have to put in the number of characters to put in. And I think it's okay if it's higher than the actual number that you have. Let's just have a look here. Oh, no, it didn't like that. It started putting in gibberish. I guess that makes sense. That's whatever data is after these characters in memory. So you got to make sure that this actually matches the size of whatever you want to write to the file. So there's one more thing that I want to talk about before the end of the video, and that is if you want to figure out exactly how many characters are in a file. So if you want to dynamically allocate a character array large enough to hold all of the whole file, let's make an ifstream object. I'll call this, I'll do the poem this time. So now we can actually use the poem for something. I think I called it poem.txt. So there are two methods that I'll introduce you to here, the seekg method and the tellg method. So I'm going to do infile.seekg, and this takes two arguments, so 0, comma, and yeah, this is where I got confused. This is iOS underscore base, and then end. So yeah, earlier it was just ofstream, and then the scope operator. This one is iOS underscore base. And so this just will take this by the way is the get cursor sort of. And so, you know, if you're getting one character at a time, you can put it at the very end. And then position equals infile.tellg. So tellg will tell you the position of the get cursor at that time. So this will actually tell you the number of characters that it had to go out to get to the end of the file. And so now we'll put the cursor back at 0. You don't need a second argument unless you're moving it to the end. And now we can make a character array. Call this our poem array. And this needs to be exactly, well, we'll make this a dynamically allocated array, and we'll set this into an array of exactly position number of characters. And this is when using the read method can be very useful. So we want to read into poem array, and we will read exactly position number of characters. It might make more sense to call this length actually, but I hope you understand why I called it position in the first place. So now we can see out number of characters is length, and then file, and then we'll see out the poem array. Oh, something that I've been forgetting to doing. It's somewhat important forgetting to do. It's somewhat important to be closing your files when you're done with them, just so you don't have them open anymore. That's just an operating system thing, but it's important to do, and I haven't been doing it, but that's because these are pretty small examples, but it's just important to remember to do that. So now that we've read the whole contents of the file into our array, we don't need to have the file open anymore, and so we can just go ahead and close it. whether we don't really need this endl at the end, but put it there anyway. So if all goes according to plan, this should give us our whole poem. Indeed it did. It tells us there are exactly 732 characters, and it outputs the whole poem, and the file is unchanged. So that's how you can use the seekg and tellg methods to figure out how many characters you need to contain the entire file in an array. You can also move around the seek. You can do seek p to move around the put cursor, so that's for doing output with ofstream. Seek p and tell p. The only thing you need to know about working with seek p is if, say, you've output the word apple to a file, and then you move your put cursor back a few characters. If you now start typing, it's not going to insert that in the middle. It will actually overwrite. It's hard to demonstrate this because Macs don't have the insert key, but it would actually overwrite the rest of the word. It wouldn't insert it in the middle. So that's just something to remember. Okay, so I hope I've given you, it's kind of a long video and I apologize for that, but I hope I've given you a good overview of how to read and write to text files from your program, and you can use this to implement a number of the things I mentioned at the start of the video, such as an error log system, high scores, or a settings file. So I hope you enjoyed the video, and I'll see you next time.